Yes, so let's say we have started with some input, and after that, after the first thing we have encountered as a digit, so it will transit to the state 2. Then let's say there is a decimal point, okay, then it is going to the state 3. Okay, then after some another, after a decimal point I have some another digit, okay, digit, decimal, digit, okay, then it will transit to the next state, because unsigned number is defined like this only. Then if I am encountering the exponent, okay, after exponent it will go to the next state, right? Then if I am having a positive or a negative exponent, then it will go to the next state. Same way, after that if I am having a digit, it will go to the next state, and after that if I am having a digit, it will go to the final state, that is an unsigned number. So this will also be a, if I am having the digit after an exponent, then also it will go to the final state. Similarly, if I am having this and this is my final state, okay. See, after a digit, then a decimal digit, some exponential, whether it is a plus or a minus, and then some another digit, okay, and followed by some digit or any other, let's say another decimal also, but then also it is going to remain an unsigned number, so it will go to the final state. So any other thing will also lead to the final state. So this is how our transition diagram is being constructed. It's just that we need to see that after giving an input or reading an input string, how the state 1 is transited to the state 2, okay, at which state it is being transited, that is important. Okay, next up we have the finite automata, for FA for a short. So finite automata are the backbone of the pattern recognition in compilers. See, in simple terms, a finite automata is a machine with some finite number of states, okay, that reads some input and makes the decision based on the characters it encounters, okay. It always processes the input step by step, okay, and produces the yes or no, whether the string is being accepted or not, at each time, okay. It reads the input, okay. So it is a mathematical model which is used to represent and recognize a regular languages. There are two types of finite automata, that is non-deterministic finite automata and deterministic finite automata. Deterministic finite automata means the output transition state is being determined, okay. That is only one specific path for each input symbol from a given state, okay. So if I am at a state 1 and if I am reading 0 as an input, I can transit to only state 2, so I can determine my path to my destination state. But when I'm talking about non-deterministic finite automata, it has multiple paths for the single input. So let's say one is reading the 0, okay, symbol 0, then it can even transit to state 2 and state 3 both. So it is non-deterministic that which path to be chosen, okay. So that's it about the finite automata. Let's start with the conversion of regular expressions to non-deterministic finite automata using the Thompson's rule. Thompson's construction is mainly an algorithm which is used to convert the regular expression into an NFA, and it is helpful because working directly with regular expression can be challenging for a lexical analyzer. So by converting the regular expression into an NFA using Thompson construction, we get a structure that is easier to process. So here is the general idea. See, for each component of a regular expression like concatenation, union or repetition, Thompson's construction provide a way to create a corresponding NFA fragment. Okay, so these fragments are then connected together to form the final NFA, which can be used to recognize the tokens that match the original regular expression. See, I'll explain you the Thompson's rule step by step for each of the operations. Start with the first rule. Our first rule is if my input is null, okay, so I want to construct the NFA. So this is my regular expression. Let's say my RE is equal to null, okay, or epsilon. Then I need to construct an NFA for this. Then how will I construct the NFA? See, let's say this is my initial state, okay, so this is known as initial state. We indicate the initial state by this opening arrow, okay. Then when I am reading the symbol null, that is epsilon, I'll be transited to the final state. So this is my NFA. Okay, let's say for some constant A which belongs to sigma, I want to write I have already discussed that the regular expression, we have already discussed the definition of the regular expression, where if some constant A belongs to sigma, then we say that its regular expression is A. So for some regular expression A, I have to create a NFA. Then how will I create? See, this is my initial state. So upon reading input symbol A, I should be transited to the final state. So this is A, and I'll be transited to the final state. Final state is always represented using the double circles, right? Concentric circles. This I have not explained because this is the basics of the TOC, which you all might have already learned. See, this is a NFA. NFA is mainly represent such that it satisfies the regular expression which takes some input and the string is being accepted, okay, by when I transit to this final state. Similarly, if for example for a regular expression, my another regular expression was that if I have performed L1 union L2, then my regular expression was what? R1 plus R2. Okay, so let's say I have a regular expression A or B, okay, or let's say A plus B. Then how will I do this? See, first of all, the basic of this Thompson construction is divide this regular expression into individual components. See, first of all, I'll draw for A, then I'll draw for B, and then I can draw for A plus B. That's why we need to follow this rule step by step. Okay, already we have constructed for this constant. So let's say we'll do this for A. See, this is my initial state. So when I'm reading the input as A, I'll be transited to the final state. When I'm representing B into the NFA, so this will be my NFA, right? Now, upon doing this union or addition, you say, or whatever it is, the Thompson rule states that you need to introduce new initial state and final state, and then combine them using null operator, that is this. So see, here in our example we had A plus B. Okay, our regular expression for A was NFA for a regular expression A was this to this, and for B it was this, right? Now what the rule says that we have to introduce a new initial state and new final state. So this is my new initial state and new final state. Okay, now I need to represent this both, I need to combine this both. So I'll combine their initial states with the null operator, and this will remain as it is. So this is A and this is B. Okay, so what we need to do is we need to connect this both as we are doing union with them. So for the union, the Thompson rule states that we need to introduce one initial state, one final state, and we have to join this initial state and final states with both of them using the null input string. Okay. Then our next rule for the operation is concatenation. Okay, concatenation operator, that is dot. Let's say C for the example A dot B. Okay, now see, the rule of the Thompson states that we have to make only one final state and one initial state. Okay, so the initial state of this first regular expression will be treated as the initial state, and final state will be the final state of the last regular expression. Okay, or the input symbol of this, that is the initial state of A will be the initial state of A dot B, and final state of B will be the final state of A dot B. Okay, let's see with an example. See, A will be represented as what? This. When I have A, I'll be transited to the final state. Similarly for B, when I have B, I'll be transited to the final state. Now, when I'm doing concatenation, first of all, my initial state will be what? Initial state of A. So this will remain as it is. Now my final state of A will be joined with the initial state of B. Okay, so see, this will be joined with the initial state of B, and final state of A will no more be the final state. Okay, so this will be connected to this. Okay, so in simple terms, we are just combining this both NFAs as we are doing the concatenation. Okay, our the next operation is clean star. Okay, let's say I am doing clean star of A. See, there are 3 steps we need to follow when we are doing the Thompson's construction on this clean star. The first one is we need to add a new initial state. So we need to add a new initial state. So this will be my new initial state. Then the NFA of the A. So this was my NFA of A. Done. Then I have to introduce a new final state also. So this will remain as it is. I'll just introduce a new final state. That is, this will remain as it is, and I'll be introducing a new final state. Okay, see, in NFA null, or whenever you are constructing an NFA or an NFA null, always remember that whenever you are introducing a new state, you have to join it to the existing states using the null. Okay, you can see, you can write epsilon also instead of this. So in several books you will find epsilon instead of this null. The third step is we have to combine the initial and final state. Okay, so for combining the initial and final state, see, earlier this was my initial state of A and final state of A. So this both will be connected. So it is connected like this. And this was my initial, this is my initial state, this is my final state for now. So I'll be connecting this both. Don't worry, you'll see the examples, you will get a better understanding. So this is connected like this, and this was connected like this. Okay, don't worry, I am giving you examples. See, for example, I'll take an example which illustrates all the rules, right? Let's say I'm having a regular expression as A star or B star whole star. Okay, so this can be written as A star plus B star star. See, whatever representation suits you, you can write in that form. Okay, it can be represented as plus or also. See, what we need to do is we need to start with individual components. So first of all, we'll draw A star, then B star, then we will concat the we'll do the union of them, and then we'll perform the clean star of this NFA. Let's first construct the NFA of A star. For constructing the NFA of A star, first what we need to construct the NFA of A. So what is the NFA of A? This is the initial state. On upon reading A, I'll reach to the final state. What were the rules for A star? First we need to introduce the initial state. Okay, new initial state. So this will be joined by null with the NFA of A. Second rule was what? Introduction of the final state, new final state. So this will remain as it is, A, and this new will be my final state. Okay, what was my third step? To join the initial state and final state. So it was joined like this, initial state, final state, and this is my initial state and final state. Now what is the next step? That is A star, it is created. So this is my A star. Now let's create B star. See, the A star and B star will be same except that here the input string will be B. So let's keep it like that, A, B, null. If you want to practice, you can draw the B again. Okay, this will give you the same thing, because the only change will be in this step, other steps will remain same, right? Now let's see A star plus B star. Now remember what were the rules of the union. First we need to introduce the initial state, new initial state. So this is my new initial state. I need to join here A star, I need to join here B star, and that will be joined to the final state. Okay, this needs to be my diagram. So let's draw. So instead of this is my initial state, this is my null. So what was my A? Oh, this is my A. So this null, then A, null, final state. This is null. Then what was this? From here to here, right? Yeah. Similarly for B, null, B, null. So this will no more be a final state, okay? Because we have introduced a new final state. And this will be connected by null, this will be connected by null. So this is my answer, right? Now what is next? That is A star plus B star whole star, right? So we need to perform clean operation on this. So what were the steps to perform the clean operation? We need to introduce a new state, initial state, new final state. So let's introduce a new state. I'm just doing changes here, okay? And this will be converted to the final state. Now what was the condition to join the initial and state and final state? See, my earlier transition NFA was what? This one. So I just need to join both of them. So I'll join them as this, okay? And I need to join this both. So this is my transition diagram. Sorry, this is just messed up, but you understood the point, right? Because I have already discussed the rule there for the clean operation. So with this, we have a wrap for today's topics. We have covered the transition diagrams, finite automata, and the Thompson's constructions. All are the key techniques for recognizing patterns within the lexical analysis. In the next video, we'll take this a step further and learn how to convert an NFA to the DFA, which simplifies our pattern matching process even more. Okay, so make sure to comment, and if you have any questions, I'm here to help. See you all in the next video. Thank you.